Hello, welcome to GCSE Bite Size Science with Dr. Chris Smith and with Dr. Kat Arney. We're from The Naked Scientists. In part 1, we found out how animals have adapted to live in very cold environments, like polar bears from the frozen Arctic. But what about the opposite situation? How do things become adapted to life in very hot places?
A great example of an animal that's beaten the heat is the camel, and they live in deserts, which of course are hot and dry during the day, but can get very cold at night, and there's all that sand to deal with.
So what have camels done to cope with these conditions?
A major problem for camels is the temperature. So they have thin fur on most of their body to let the heat out, but on top it's very thick, and this protects them from the burning sun and also helps to keep them warm at night. Another thing is camels have long necks and legs, meaning they have a large surface area to volume ratio, so they lose heat easily. And they can also stand a body temperature of up to 42 degrees centigrade, which would be really damaging to animals like us humans.
But what about other things like the sand?
For a start, camels have got large, flat feet which spread their weight on the shifting sand. And they also have slits for their nostrils, as well as a rather impressive 2 rows of eyelashes to keep the sand out.
And what about water? Is it true that they keep that in their humps?
No, they don't. That's a myth. They actually store fat in their humps, although this can release water when it's broken down. Now, camels are famous for being able to go for long periods of time with no water at all, and they've got lots of adaptations to help them. For example, their kidneys are very efficient, and they lose very little water through their faeces and urine.
What about plants that live in these environments? How do they survive with so little water as well?
Think about cacti. Now, these are perfectly adapted to survive in the heat of the desert. Most obviously, these plants have sharp spines rather than leaves, and this helps them to stop losing water by transpiration, as well as stopping them from becoming a snack for camels and so on. So not only that, their stems can store a lot of water in them, and they've got a waxy surface to keep water in. And their roots actually tend to spread a long way underground to get water from a very large area.
OK, well, apart from adapting to survive in different climates, what are some of the other ways that animals and plants adapt to survive?
Many animals and plants have evolved rather clever ways to stop them from being eaten. So, for example, plants like nettles sting us, while others have thorns. Wasps and bees can also sting to protect themselves. Now, some animals and plants are also poisonous, and these are often brightly coloured to warn predators away from them. Ooh, I'm nasty, stay away. And in fact, some harmless animals and plants actually fake it and try to look like a poisonous or dangerous species to fool predators and increase their chances of staying alive.
So we've got all these different animals and plants living in different habitats around the world. Are there any problems with that?
One big problem for ecosystems is that habitats only have limited amounts of the resources that animals need, so they have to compete for food, water and space. And also some animals might compete for mates as well.
What about the plants?
Plants make their food from sunlight using photosynthesis, so obviously they don't need to compete for food, but they do need to compete for that sunlight. They also compete for water, space and mineral salts in the ground.
And what about us humans? We're competitive, surely?
We certainly are. We compete with animals and plants all over the world, and mostly we're winning. So, for example, our farmers compete with animals and plants for water and space, and with other animals for food, but this can cause problems, such as the destruction of habitats to clear space for farms, or when humans remove a lot of water from the environment for our use.